So our next speakers will be from AMS-IX, the Amsterdam Internet Exchange, where we will have another double presenter slot. We will welcome Maxx Cherevko, Network Architect from Amsterdam Internet Exchange, and Ruben van der Brink, who is the CTO of AMS-IX. So please join me in welcoming them to the stage.
Thank you very much. A very good afternoon to all of you. My name is Ruben van der Brink, CTO, and Max will join us later. He's the co-presenter of today. First of all, I would like to thank Netnod for organizing this meeting and inviting us to speak here. It's a great opportunity to share some of the things that we have been working on. So maybe first about AMS-IX, for those who don't know. We are an internet exchange located about 20 milliseconds southwest from here. And we take pride in ensuring that all of your cat videos and explicit content reaches you with a minimum of latency. And at times we do so at a peak traffic of about 12 terabit per second. We operate globally. So currently we have about 17 exchanges in the world and over 1,000 networks connected. So although I do expect that a couple more dots will come on this map in the future, I want to emphasize that it's not just growing for growth's sake what we do. Don't worry, today will be mostly a technical talk, but I do want to use this opportunity to tell you a bit more about the mission of AMS-IX, which is a better society through better internet. And that immediately begs the question, what do you mean with a better society? And also, what do you mean with a better internet? Well, the answers to these questions, of course, depend on who you talk to and in what region you're talking to these people. But to me, it is mainly summarized by be the exchange you want to see in this world. And we have defined 3 pillars, which we use to give direction to how we want to go forward. And the first one is, we believe that internet exchanges really build on neutrality and independence. This is and always be the most important pillar for all internet exchanges going forward. So secondly, we also believe that when you go back to your hotel room and you take a glass and you tap some water, it's safe to drink, right? However, if you want to go on the internet, as soon as you open up your laptop, you're being harassed, you're being potentially people stealing your identity, your data. There's a lot of threats that come over there, and we do think that the internet should be a safe place. And finally, but of increasing importance, is sustainability. Right? The digital services industry used to be part of the solution. Right? By digitizing, we would become more sustainable. However, the increasing impact of the use of digital services has made it that we are actually part of the problem now, right? We have data centers growing everywhere, and I'm talking about, well, the amount of energy it uses to do a Google search, or maybe offload some work to ChatGPT, and yes, also your occasional Netflix and chill night. Contributes to this ecological footprint. So we need new solutions to make sure that in the future our industry becomes part of the solution again. For that, ladies and gentlemen, innovation is key. And I'd like to think that there's 2 kind of directions or 2 categories of innovations that internet exchanges can look at. And the first one I like to call horizontal innovation, which means that you broaden your service portfolio with existing network functions, like cloud access, transport, security. Well, cross-IX is where you allow access to another VLAN from another internet exchange. And the problem with these kind of innovations are that it might piss off customers. Right? Sometimes people think, well, it's not up to internet exchanges to offer such services. Right? They think that internet exchanges should remain doing what they're best at, which is providing B2B peering at certain strategic connectivity locations, and don't do anything else. However, we need to innovate to address the bigger problems in life, I think. So we also need vertical innovation. And by vertical innovation, I mean that we use this trusted position of internet exchanges worldwide to develop new services, like for instance Netnod has been doing with providing time services, but also an innovation project of AMS-IX, which is data exchange. I will talk about that at some other occasion. And in the future we might even think of providing quantum exchange services, whatever that may mean. What you do then is you build on your neutrality and independence, and you offer new types of services going forward. And this does not interfere, I would say, with the existing membership. So giving these two directions, sometimes you're just taken by surprise. And innovation comes from a whole different direction. So next up, it's Max. And Max will tell us the AMS-IX story of photonic cross-connects and the importance of redundancy in our platform. So it's about the historic pursuit of service availability, about a company that went out of business, about mirrors and a Raspberry Pi, and in the unlikely event that you don't care about any of these things, then please remember this one takeaway: don't ever underestimate the strength of a Friday afternoon project.
Thanks, Ruben. So my name is Max, and I'm working for AMS-IX more than 10 years. Currently, I'm holding the position of network architect, and I'm going to tell you the story about technical part and technical aspects of internet exchange overall. So this is a slight history about our topology change. Like we had ring first, then we had double star with VSRP switching, and finally at 2009, we migrated to spine leaf. For data center guys, it's really important to have that. You all know the advantages of that, and I don't want to list of them, but I want to emphasize on red lines on the slide, especially on potential random lock-in that we experienced last year. So we have this topology. It's nice. It's nice to operate, it's nice to manage, but it has also the drawbacks. So what happens, for example, if your customer is always connected with usually one line or lag, right? But to the same switch. In EVPN, you can do the dual homing, but not in our case. So what happens, for example, if optics died? This means that service is affected for customers at least for hours. You need to replace optics, you need to send engineer to data center, or you need to order the remote hand support if it's somewhere in Singapore, for example. Line card dies. It always longer than at least hours to replace, right? Some kind of problems with software bugs, CPU is overloaded with some bump traffic or whatever. Unlikely event of both fiber cards, also possible. It means it will take days to fix that. And if the chassis dies or the pizza box dies, again, if it will be fast enough in your location, but if it's somewhere in Bangkok, it will take weeks to replace it. So how to avoid this downtime? Yes, I understand that you as a customer, you will reroute the traffic for that. But I'm sure that you don't want to do that, especially with, when it happens many times. So how to solve it? What if we put the second P? Like, everything is isolated now, right? So we have separate backbone, separate line card, separate optics, right? Cool, but how to connect one customer to two Ps simultaneously? Any ideas? Okay, so layer 1 switch. It's a really nice device where you terminate connection of the customer on this device, and which is kind of switching the light towards certain PE. So in this case, it's kind of remote patch panel. So you can operate it remotely. It doesn't matter where it is. It's in US or in Australia. It's able to map any to any. It's really fast swap, so it's less than 25 milliseconds. This means that you as a customer will notice just the short port flap. So BGP sessions stay intact. So you don't have to reroute any traffic. This is our current design of our AMS-IX Netherlands that we have. We have to every PE, one photonic cross-connect, or multiple, it depends on the amount of ports because they are different flavors. Sometimes it's not enough ports on a photonic cross-connect to cover one PE when you have 280 or 300 something ports. When the customer member calls us, for example, we lost light from you, do something. Our even operator goes to the panel, click a button, and it swaps the customer to another PE, which actually isolates all the problems possible with a backbone, line card, CPU, management module, whatever. But also we have a special tool which monitors health of the platform. We monitor LSPs, and in case if one PE becomes isolated for any reason, all other PEs signal about that. And this tool, it's a homebrew tool, we call it PXCD. It takes a decision and swaps automatically all the customers to the redundant PE. And actually, I was checking the logs because the time of the swap is really fast. It's less than 25 milliseconds. But you need to receive LSP, SNMP traps. You need to take a decision. It takes up to 2 seconds. So still, BGP session will be fine. What, for example, if you want to replace the unit or upgrade the unit or reboot the unit? We always do swap customers, do whatever we want. It may take days or weeks. And then we redistribute customers to the primary path. Yeah, Glimmerglass has left the building. Yeah, this is the devices that we use. We call it, it's named Glimmerglass. We have around 70 units in production. Very nice units, low power, works perfectly, but nothing lasts forever, right? So we have a couple of units already, which are lying in our shelves because they are dead. And the problem here is that they left the business. They become bankrupt 2018, and officially they're out of business 1st of January 2019. But we still want to have this service level that we provide to our members. So how to proceed? There are a couple of vendors who does that, actually. We can find and buy them, but they're extremely expensive. So one unit may cost around 300,000 K, which will make our prices, of course, much higher, right? So we decided to investigate, and after some Googling, we found this nice device. Small one, it's a relay. It's just like a switch. So you can, as you can see, 1 in and 2 out. This is exactly what we need. It's latching, which means in case of power loss, it stays at the same position, which not in the case with Glimmerglass, because once Glimmerglass loses the power, it's dropping all the connections, which happened. And shame on me here, but once on a data center, I just unplugged accidentally the power of Glimmer. And all the customers who were connected during the period of reboot lost their connections. So it's, as you can see, it works from 1310 to 1650, which means it's DWDM, also possible to, it's even faster. It's 8 milliseconds. And last but not least, they're cheap. What we did, I ordered a couple of them. As you can see, all amount of things, what was involved into this small project, into proof of concept, just to see if it works. So, and I ended up with this one. It's a photonic cross-connect, yes. Nice. And Raspberry Pi is the management module. It works for 2 customers. We put it in the lab, and it showed the perfect results. So why not? We need to do something bigger, something on production layer. You don't want that to have that, right? To be connected to this device, right? So we started to think how to design the production unit, the big one. So we looked at the Glimmer glass, so why not? Why not to do the big one with LC connectors? And then, yeah, this is our drawings. At some point, we just realized, stop, the rack space is not so cheap nowadays, right? So you want to save money. And how to save? Because the biggest thing, it's a rack unit. You can make as deep as you want, up to 1 meter, right? But the front space is money. How many LC connectors can you put on one U? 48? Maximum. This is what I saw. So not much that you can do. So you need to do something more dense. And we came with MPO MTP connectors. So we use MTP24, which has 24 lanes. As you can see on the breakout cable, we use only 8 out of 12. There's a reason behind that, but that's the technical details. And you can see how is it mapped on the relays itself, how light passes, and how actually it works. So LC connectors are connected usually to the switch itself, and the MTO NTP is going to this unit. At the end, this was the minimum viable product. You can see that we had 2 rack units with 8 optical modules. At the end, it's 8 by 12, because 12 relays in the module. You can actually see them. This is the relays. But unfortunately, the factory that we did that, the quality was not so good. You can see the fibers are lying like this without proper positioning. And again, the Raspberry Pi was still the management module. Why not? It's interesting, but again, you also don't want to put it into production, right? You need something more serious, right? At the end, we hired the professional company. This company is located in Ukraine, and it's called Taratel, and they made these nice devices. So they made 2 flavors, 1U, 2U. In 1U, you can fit 64 customers, and as you can see on 2U, it's 10 modules, 160 customers. What we did here is modules are interchangeable, so you can put module out of 1U and put it horizontally or vertically in 2U, which makes our stock more rich, because we don't need other flavors of that. This is some boring for some people not, internals of that. So it's really low insertion loss. In total, it's up to 2 dB. On Glimmer glasses, it was 3. So it's already improvement. Another thing is, as I mentioned, latching. If you're losing power, we can even take out the management module without anything. Everything stays intact. Dual power supply. NXP AMS-IX as a management module, as the heart of the unit. Really low power consumption, 15 to 16 watt. Of course, you need just power to keep relays in a certain position, just to make sure if in case of vibration, because they're afraid of vibration. So we still feed some low power to them to keep them into the certain position. So 15 to 16 watt is nothing. Fast swaps, yeah. Software, of course, we need software. Hardware is one part, software is another. So we made web UI. It looks like this. So you can see position of the relay. You can see the light level. You can click. It will swap immediately the customer. Nice? Nice. But as we know, almost no one is going to web UI now. We need some automation. So we designed the REST API for that. So you can use CURL or Python or Perl, whatever you want, to operate with the relays. You can see how it works, how it reads power levels. Yeah. And we can also do the TX-RX detection, which often happens in data centers when we do the patching. They do it other way around. So that was the story of our development. And I'm proud of AMS-IX team and TerraTel team that they have made great devices. I'm giving word back to Ruben.
Yes, please. How cool is that? I mean, we are so proud of having an AMS-IX device in our racks, right? Suddenly we're in the hardware business. We wouldn't have expected that a couple of years ago. So from a Friday afternoon project, it turned into this. But where are we now currently in reality? We have UAT testing going on. So we have a couple of prototypes. You saw the pictures of them in the presentation that Max just delivered. And so we're testing all kinds of scenarios if they actually work as expected and with all the specs, the great improvements that Max has realized in those prototypes. So we aim to place the first batch of production before summer. It will take some time to build those machines, but that will hopefully give us enough time to have a first deployment in 2024 in our platform. So that's the hope. That's what we're aiming for. We've spoken to several IXs about this technology, and they're really interested. So they said, "Hey, can we also buy this equipment?" So we're not in the hardware vending business, but we said, okay, if we believe that they're good enough, then we will certainly consider to make these devices commercially available. Now, as an encore, I would say we have an innovation manager at AMS-IX who was inspired by this story, and he was doing a little project with gamification in virtual reality. So he took the MXC as an inspiration for one of these devices, and he allowed me to give you a sneak peek of what that would look like. We aim to launch this VR game at the More IP event in Amsterdam by the end of May, but I can already show you a bit what it's like. So you are a player in this virtual world, and of course your job is to redirect the beams that are coming your way, inspired by the Max Cross Connect. Ladies and gentlemen, thank you very much. If you have any questions, we're happy to answer.
Thank you. We have some time for some questions. Any questions? Yes, Arvid.
Hi, Ben, BGP Tools. You said that around the 25 milliseconds or some milliseconds for switchover. 2 questions on that. You said that like the BGP sessions will stay alive. Most router chassis, if they are connected directly, will shut down BGP sessions if the link is detected as being down. But the second thing I have a question for on the same subject is, when you go faster than things like 10 gig, the optics have brains in them and have digital signal processing. How does that interact with being photonically switched to another switch?
1 second, your mic needs to be switched back on.
Yeah, I'm online. About BGP, we know about that, and on our website you need to configure a special command which do not signal to BGP in case of port flap to shut down. Yeah, I don't remember. I don't remember the exact command. So on every vendor is different. And I didn't really understand the question about 100G or whatever. So we don't have any problems with that. It works.
Oh, okay, fair enough. I was curious because they have more advanced digital signal processing.
But it doesn't matter, it's just a mirror. It means like you just take out from one optics and plug it into another.
Sure, I guess, never mind. Yeah, I think I understand the
okay.
nuance now.
Mm-hmm.
Yeah, hi, Dmitry Kakhmanyuk from Hostmaster. Well, I'm glad you're using Ukrainian technology. Maybe they want to replace that bankrupt vendor. and maybe you should put their name into the slides if they don't mind. But have these things ever failed on you themselves? I assume they're reliable and all.
Excuse me, I didn't get
Any failures with this equipment? Is it very successful, operational?
We are still doing the user acceptance test, which
Alright.
includes the
Okay.
stress test. For example, we'll run swapping for 10,000 times during that. So, yeah.
Great.
Actually, again, if it has a mirror. It just stays in this position. Everything around is just management of that, right? So nothing can break. So at least you will stay at the same position. So the light will be reflected. We don't expect.
We did test if they catch fire, right?
Yeah.
We destroyed one in the
We
in the
sent for
certification process.
certification. They destroyed
I mean,
one of
I'm
them.
sure nothing ever failed at M6.
Yeah, of course. Thank you.
Good luck.
Yeah. You talked about possibly selling it, and someone at the internet is asking if you are possibly planning to make it open source as well. Oh, it's me over here. But the question is from someone who asked it anonymously. But they want you to make the parts that don't cost money open source.
Well, the software or
I guess,
the design.
and possibly the design. It doesn't specify, but I assume all of it. If you don't want to sell it, you could possibly put the plans online and someone else could build it for themselves or to sell it.
We make it into a hobby project.
Yeah.
I mean, I want one at home myself, so...
I think we have one more question at the back, and then we're going to have to go to the next presentation.
Hi, it's Ronan Kelly from Adtran. I was actually going to ask two questions, but the previous audience member kind of touched on the second one, which was about publishing a reference design. But the first question I was going to ask was, it was along the lines of the reliability piece. So traditionally with MEMS-based switches, quite often the failure mode that gets encountered is when the thing hasn't been switched for a very, very long time, and then something breaks and you need to switch it, and you know, things like the greases and stuff like that that move the MEMS mirror have dried up and failed. Is there any data available from the component manufacturer you're using with regard to, you know, non-active states and then suddenly becoming active again? What sort of failure rates do you expect there?
No, I don't remember. There is a specification of that unit. We can meet later on. I can send you the draft or the document. I don't remember. They have for time and for amount of switching. The relay itself is in vacuum, so it doesn't get any dust or something. Yeah, this is the challenge. I don't know how it will work, but fingers crossed. It looks promising.
Okay,
And maybe just to add a little, it's used for more than just a fail-safe. So because it's also used operationally, I think most of the active connections do get switched. You know, not like only once at every 5 years.
Perfect. Thank you.
Okay, so for purposes of time, we have to move on. So please join me in thanking Ruben and Max for a fascinating presentation. Thank you, guys.
Thank you.